Hi folks, welcome back to 7.6, video number 2. So last time we talked about how to find powers of complex numbers, and we found that we could use de Moivre's theorem to figure that out. And now we're going to take a look at the roots of complex numbers, and we'll get a chance to practice one example with radians and one example with degrees, okay? So let's scroll down to example number 3. So, example number 3 says find the cube roots of z equals 8 cis 2 pi over 3. Now, I see the word cube roots, and I know immediately that I'm going to have 3 answers. Okay? So at the end of this, I should have 3 different answers. If I asked for the square root, then I would only have 2 answers. If I asked for the 4th root, like we'll see in the next problem, I want 4 different answers. Okay, so step 1, we're going to go ahead and use our formula. So z to the 1/3, that's the same as a cube root, is going to equal r to the 1/3, and then cis 2 pi over 3 times 1/3. Okay, so that's going to be our starting point here. Now let's go ahead and find the first one. So first thing we're going to do is just simplify this equation. And so when we do that, we're going to get z to the 1/3 equals 8 to the 1/3 cis 2 pi over 9. Okay. Now this is going to be the first of our 3 answers. All right, so this right here is going to be a special case when k equals 0. Now if you're like, well, where's the k in the equation? What I did is I wrote 8 to the 1/3 cis 2 pi over 9 plus 0 pi over, sorry, not 0 pi, 2 pi k over 3. Okay, now the k is 0, so this whole second part went away. And if we wanted to simplify our answer more, we could actually write z to the 1/3 as 2 cis 2 pi over 9. This is probably a better version than the 8 pi, or 8 to the 1/3. So that's one of our answers, but we have 2 more to find. So find 2 other answers. So here are where our 2 other answers come from. We can say 2 cis 2 pi over 9 plus 2 pi times 1 over 3. And in this case, what we're doing is we're saying that k equals 1. Okay? And now when we clean this up, we'll get 2 cis 2 pi over 9 plus 2 pi over 3. And we have to combine our fractions by creating a common denominator. So this will be 9, this will be 6 pi, and that will give me 2 cis 8 pi over 9. That will be our second answer. Now to find our third answer, instead of k equals 0 or k equals 1, now we're going to plug in k equals 2. So I've got 2 cis 2 pi over 9 plus 2 pi times 2 over 3. And again, this 2 is because k equals 2. And when we clean this up, we'll get 2 cis 2 pi over 9 plus 4 pi over 3. And same thing as before, I have to make a common denominator. And when I simplify that, I'll get 2 cis 14 pi over 9. Okay? And so there you have all three answers. And again, we knew they were 3 because we said cube root of an answer. And we're looking to plug in k equals 0, 1, and 2. So we always start with 0 to plug in our k's, and then we plug up all the way until 1 less than the number, like the cube root will plug in 0, 1, and 2. But if I were looking for the fifth root, I would plug in 0, 1, 2, 3, 4, and then I would stop, okay? Let's go back up to the equation for a moment to take a look at that. So here's our equation, okay? So we took the root, and then this inside part, sometimes I split this up into 2 different fractions. That's what I did when I wrote it. So for example, I would write this as theta over n plus 2 pi k over n. So that's how I wrote it down below. And if you wanted to split the fraction for the degrees, you could write it as theta over n plus 360k over n, and that would get you the same answer. All right, so let's go back down and work through one last example to find the roots of complex numbers. Okay, so example 4. This says find the fourth root, so I'm going to have 4 answers. And right off the bat, I'm going to write down which k values I'm going to plug in. K equals 0, 1, 2, and 3. Remember, I stop 1 less than whatever number of answers I have, because this is 1 answer, 2 answers, 3 answers, and 4 answers. Okay, so what did we do first last time? Well, our first step was to go ahead and plug things into the formula, and then we simplified to find our k equals 0 step. So that's what we're going to do here. So step 1, we're going to have z to the 1/4 is going to equal r to the 1/4 cis of 120, which is my angle measure, divided by the number of roots that I want. So divided by 4. Okay, so last time we divided by 3, or we multiplied by 1/3. This time we're going to divide by 4, or multiply by 1/4. Okay, so let's get our r in there. So we have 16 to the 1/4. Cis of 120 divided by 4 is 30. And so I can clean this up even more to be 2 cis 30 degrees. And this is actually going to be my k equals 0 case. Okay? Now from here, we can find other answers. And so we're going to do this by adding the plus 360k over n. So the next answer is going to be 2 cis 30 plus 360 times 1, because k is 1, over 4. And when we clean that up, we'll get 2 cis of 30 plus 90, or 2 cis 120 degrees. And this is the case when k equals 1. So we've got 2 of our answers so far. We have to find the other 2. So we repeat. 2 cis 30 plus 360 times 2 over 4. And this is the case where k equals 2. And this is going to simplify to be 2 cis 30 plus 180, which is going to be 2 cis 210 degrees. And that is our third of 4 answers. And we have one last one. 2 cis 30 plus 360 times 3 over 4. And again, that 3 is because k equals 3. And then we're going to do 2 cis 30 plus 270. And that's going to give me 2 cis 300 degrees as my fourth and final answer. Okay, so not too bad, these problems, a lot of plugging into formulas and making sure you know your unit circle, but all things that I know you can handle. So make sure to practice more problems like this just to get a little bit more familiarity with this, and make sure that you have that unit circle on that cheat sheet for exam number 4, okay? All right, so this finishes the content here. Let me know if you have any questions, and I'll talk to you soon.